In this question from the chapter light based on mirror formula, it says there is an object which is placed at a distance of 75 centimeter in front of a concave mirror. So we have one concave mirror and the radius of curvature of this mirror is given as 1.25 meter. Now the question is, where should the screen be placed? We know that the real image is formed on the screen. That means we have to find the distance of the image, right? So the distance of the image is same as the distance of the screen. And further, we have to find the magnification produced by the mirror. And later we have to show this using diagram. So first I'm going to make a concave mirror just to get an idea. Let's say if I make one concave mirror, as you know that the reflecting surface of a concave mirror is curved inward. So let's say this be the reflecting surface, and these are the back side of the mirror, which is said painted. Now I'll make the principal axis, that is a line joining the center of curvature to the imaginary line, joining the center of curvature to the pole of the mirror. That means I can take this point as the pole. Let's say this be the principal focus and this be the center of curvature. So if I see the information that we have is number one, the object distance, that is object distance is denoted by U. And as you know, by convention, object is always kept on the left-hand side of the mirror. So you'll be taking U as minus 75 centimeter. And the radius of curvature is 1.2520 meter. As you know that the radius of curvature is measured to the left of a concave mirror. That means this distance is radius of curvature. And as we can see here, it is to the left of the mirror. So by convention, this will also be negative. But then we have to keep these three variables in the same unit. So we'll be writing this as 120 centimeter and minus because of convention. This is 120 centimeter. Now, the question, as I said, is we have to find the distance of the screen. As I said, the distance of the screen is same as the distance of the image. That means we have to get the V as the question mark, and magnification is what we have to find out. Now, for that, first of all, we know that the radius of curvature is twice the focal length, or we can say that this focal length is twice the radius of curvature. So we can say that F here must be half of this, which is minus 60 centimeter. Now, applying this mirror formula, we can get the value of the image. So here, 1 over F, that means 1 over minus 60, which is minus 1 over 60, is equal to 1 over U, and U is minus 75. So minus 1 over 75 plus 1 over V. Now transposing this to the left, it will become positive. So this will become positive 1 over 75 plus 1 over 60 is equal to 1 over V. Now we have the LCM as 300. 75 4 times is 300. This is minus 60. So this is 4 times, and 60, 5 times is 300 is equal to 1 over V. Now we get this as minus 1 over 300 is equal to 1 over V. So by cross multiplication, we got V, which is the image distance or the distance where the screen should be placed. So we got the image so formed as minus 300 centimeter. Now later they have asked you to find the magnification M. As you can see that M is equal to minus V over U. So we can apply this relation M as magnification is minus V over U. So M is equal to minus copied, and this V is minus 300. So minus 300 over U, and U is minus 75. So here we see that these two minus get cancelled. 75 1 times and 75 4 times. So finally, we got the magnification m as -4. Now we got these two. We were asked to find out the magnification, which from here we got it, and the image distance or the distance where the screen is placed is this. Now we have to show it using ray diagram. So let's say if I extend it further, we can see that object distance is -75. So we can figure out that this is center of curvature, this distance, and this is focus, principal focus. So we can see that this 75 lies between, ignoring the sign, it lies between 60 and 120. So clearly the object is placed between F and C. So we'll say that the object is placed over here. Now for further ray diagram, what we'll do, you will draw a ray, first of all, parallel to the principal axis. So if I draw a ray parallel to the principal axis, let's say, if I draw a ray parallel to the principal axis, it should pass through the focus after reflection. So it's passing through the focus after reflection. And the second ray you'll be drawing, which say if you draw the ray, let's say, passing through the principal focus, after reflection, it should become parallel to the principal axis. So the second ray will be drawn like this, passing through the, becoming parallel to the principal axis. It will, this is the incident ray, reflected. This is the incident ray and the reflected ray. Clearly, the image will be formed here. The image will be formed beyond C. And you can see it is a real inverted and larger in size. And that's the reason why we got magnification as -4.